So I'm now going to move on to our final topic with our two presenters of James Manson, our Senior Research and Extension Officer, and a collaborating partner, Ross Ballard from SARDI. We're going to talk about the pulse inoculation trials that SFS has been involved in. So James, can you just give us a quick overview?
Yeah, so just to clarify what's in your e-booklet, everyone, we have one acidic site where we're looking at end fixation from a few different angles. There's a couple trials in your booklet that weren't included in the video, but feel free to ask about them. But our focus is the trial looking at the acid-tolerant strain of Rhizobia. We've had some good results there, which you would have seen in the video. I might just share my screen quickly, though, to show you that again. One moment. Everyone see that okay?
Yep, it's come up now, you're right.
Great. So you can see in the photos there that when these are just two buffers that are side by side, on the left-hand side, it's been inoculated with the acid-tolerant Rhizobia and a couple other things just to get it up and running. On the right-hand side, no inoculant, and you can see really constrained growth. That's partly because of not having any nodules, partly the acidity itself having a direct effect on the plant. So it's a responsive site, and that's very exciting, very thankful for the host for having us. And then you saw those results in the videos. WSM1455 is the strain of Rhizobia you have currently. Doubling the rate increased the nodulation a little bit, but the big response was from using the new SARDI 969. It's supposed to be 969 in both cases there, excuse me. At a single and a double rate increased it again. Definitely improving the situation. Our control only had a little bit of background Rhizobia, and this nil checks for cross-contamination. And so pretty much it's a good trial is what we're saying. We've got really interesting results, and it's really promising for that new acid-tolerant Rhizobia. So, you know, that's pretty exciting for us. And it's great to have Ross with us, since Ross and his team have been developing this, and we're going to really benefit from it. So it's great to have Ross with us today. Ross, could you just give us a little backstory to this work and your involvement in it?
Yeah, thanks, James. So I guess the work started in 2013 when we recognised we were seeing some very low nodulation in some of our trials, and also we were getting a lot of feedback from agronomists about poor nodulation, particularly in beans in Victoria, as they were moving on to more and more acid soils. So we started the process by looking at some strains that we'd isolated from acid soils in a hydroponic test. So that's where plants are grown in liquid solutions at very low pH. And in those tests, we were able to show that some of the strains produce much more nodulation, and the strain you have at the moment, 969, is one of those strains. In the hydroponic system, it increased nodulation about 6-fold compared to the commercial inoculant strains. So that encouraged us to go ahead. Since 2015, it's been in about 19 field trials, not including the demonstrations. And just to sort of give you a bit of an overview more broadly outside of your trial, compared to the commercial inoculant strain, it's increased nodulation by about 57 percentage units, and end fixation, biomass production and grain yield in the order of 15 to 20%. So that's sort of where we're sitting with that strain at the moment. It's still being evaluated interstate in New South Wales and Western Australia, but effectively its evaluation has been completed in Victoria and South Australia. So it's really, we're just waiting on the results from the interstate trials as to whether it's 969 or there are some other strains, which one we progress with to commercialisation.
Thanks, Ross. We're ready for questions, Michelle.
So when in the video you said that the old strain will just be replaced with the new strain. If you're not having an acid problem, does it give you a better nodulation factor on normal ground?
I've only done a couple of trials for Ross on acid soil. So Ross, do you want to tell us about the non-acidic situation?
Yeah, so look, the intent will be that 1455 is simply replaced, and certainly 969 has been evaluated across a wide range of environments. On the acid soils, it's better. There's probably no difference on the alkaline soils that we've been able to measure. Above pH 5.5, 1455 is a competent strain, and so there's really no advantage of 969 on those neutral or alkaline soils, but there's no disadvantage. So the plan will be just to replace the strain and avoid any confusion about which strains go where in the marketplace, and that tends to be the strategy that we use for inoculants.
There's just a few questions in the chat box. So do we have many more acid tolerant strains in the pipeline that are coming through the system that you're working on?
Look, at the moment we're just trying to get this one out and about and see how it performs, but to be honest, I don't think it's probably the best we can do. It's sort of like wheat breeding or anything else, you know. You're always looking for the next advantage in the system. What we have got, we have made some selections out of both 1455 and 969 for tolerance to pea pickle tea. So a lot of the crops that are going out are having fungicides on them, and we know that affects rhizobial survival. So we have got some acid tolerant material with pesticide tolerance as well. So that's where we think perhaps the next opportunity for us might lie.
Yeah, and so we're seeing massive results around the Inverleigh area. So this new Rhizobium will be available in 2021, or we still haven't got the sealed deal of the date that growers can get their hands on it?
Look, initially we were saying 2021, but because it's now, there was a requirement for further evaluation in New South Wales and WA where it will also be used. It now looks like that date's going to be pushed back 1 year to 2022. There may be some limited release pending some discussions later this year or next year, but at this stage it'll be 2022 when the release happens.
And another question here: do we know how much we lose when we inoculate our seed and then we delay our sowing? Is there any better way of putting the inoculation on the seed?
Okay, just let me read the question. Do we know how much you lose in inoculation? Okay, so it's a good question, and it will depend on the formulation of product also that you use and the inoculation rate. But the biggest death rate of Rhizobium is in the first 48 hours after application. So that's why the general recommendation is to inoculate and get the seed in the ground within 24 hours if you can do so. And so you might start with, if you do the maths, the numbers that you might get on a bean seed might be between 100 and 500,000 Rhizobium, and after 48 hours that may well have fallen to 20 or 30,000. So they're the sort of numbers that you're dealing with, and then it tends to stabilise out for some time after that. Now, I guess the caveat here is that freeze-dried inoculants, the death rates are much higher because they are largely unprotected cells, and so if you are using freeze-dried inoculants, the recommendation is they're in the ground within 5 hours. So that's not to say that freeze-dried inoculants don't work. If they're used in ideal conditions, then they will work just fine, but they're certainly not as robust generally as peat inoculants. And I guess the other thing I might mention, if you're also applying pesticides, then the death rates of any formulation will be higher than if there is no, particularly some of the fungicides on the seed.
Going back to the strains, what are the timeframes currently involved with developing of new Rhizobia strains?
So this one started in 2013. I guess we already had some strains in the top drawer, if you like, to use in that process. So we're a little bit lucky in that regard. But like breeding a new cultivar of cereal or pulse, you're probably looking at an 8 to 10 year period. I guess the advantage is that when we get to the end of it, that we can multiply the strains up very quickly. So we are a bit quicker than traditional plant breeding, but it's still, by the time you've done some laboratory work and you've had a multi-state field evaluation program to make sure that you've got the best strain possible, you're probably looking at 8 to 10 years.
Thank you for that. Ross, also, could you comment on granules versus peat if you're dry sowing?
Yep. So we have been doing some dry sowing work, particularly my colleague Liz Farquharson. We had a project with Sagat that's recently completed. Our general feeling is that if you're within a week or a little bit longer than that of the break of season, then peat is probably still your best option, and particularly for pulses that are sown into the soil. It's a little bit different for pasture legumes because they're on top. They tend to be sown more shallow or on top of the soil, but pulses in the soil into a reasonably uniform environment, probably a week or so before the rain, peat is still your best option. Having said that, we have seen some good results from granules as the time extends out, and we've had some particularly good results with the Novozymes granules with beans.
So any more questions there for Ross or James? James? Have you got any comments, Ross, about liming and working with the acid-tolerant Rhizobia as well? Because you're not going to just rely on the Rhizobia to do the work for you.
Yeah, well, I think James makes a really good point with his Christmas hat, and that is it really is that the Rhizobium, they do provide the bonus, if you like. They'll provide a bit of buffering in the system, but like anything in agriculture, you know, there's no silver bullets. It's not going to solve all the problems. And as I say, we have evaluated these strains over a wide range of environments, and we know as you move down to around pH 4, which you're getting in some areas in Western Victoria, then the acid-tolerant Rhizobium just don't cut it down at that very low pH. They're really they're going to give you advantage in the range of James's trial in that 4.5 to 5 zone. They'll give you some buffering there. But generally, we see them as a tool in the toolbox to be used in conjunction with a liming program to bring up pH. And I think, as Lisa previously mentioned, to optimise production in a lot of systems, you really want to bring the pH up to sort of probably approaching pH 5.5 in the topsoil, particularly if you've got some subsoil acidity, so you get a bit of correction of that. And I guess the other reason for liming in conjunction with the new strain is that the strain only is one side of the puzzle. The other side of the puzzle is the plant. And so, for example, with beans in particular, again, going back to some of the testing we've done in hydroponics, once you start to drop the pH down below 5, their root systems are impacted by that low pH, so they shed a lot of their finer roots. So we can put the rhizobium there, but if the beans haven't got the roots, then things are still compromised. So if you bring that pH up where the beans grow well and you put the rhizobium in, that's where you get the double kick.
Are we expecting what sort of yield differences are we getting from the different rates of rhizobia by doubling and the different strains?
So in the strains, so talking broadly across the advantage of the new strain, and this is data from 19 sites, we're looking at a 14% yield increase. But just be aware, at some sites that was, 300%, and at other sites it was down at only 1 or 2%. But on average about 14%. And in terms of doubling the inoculation rate, similar sort of advantages. So you get much better, as for all these things, you see big increases in nodulation early, but smaller increases in yield, but nonetheless still significant and substantial increases in yield.
James, have you seen any differences between varieties and rhizobia in the work that you've been working on in the last couple of years?
Not that I could directly attribute to the variety, to an interaction between the variety and rhizobia. No. Ross, have you seen anything in that space?
Well, as part of the testing, we've just run a glasshouse test where we've had 10 bean varieties, and there are some subtle differences between end fixation capacity between variety and strain of rhizobium, but 969 looks pretty good on all the current cultivars. The thing I'd add, there is some work about to start at the weight, looking at developing some more acid tolerant bean varieties. So we'll need to check the compatibility of those with the rhizobium down the track. But the current strains we're working with are checked across a range of varieties to make sure there's no incompatibilities.
Ross, is there any herbicides that you should avoid applying that could adversely affect rhizobia during the season? Have you done any work around that?
Look, we are doing some herbicide work, Lisa, and last year at Horsham we had a range of herbicides applied pre-emergent. I don't have the details of what they are just at my hands at the moment, but basically when they were applied at recommended rates, there were no adverse effects on the nodulation or biomass production. We're still waiting for the end fixation results to come back for those. This year, we're actually focusing on a range of grass herbicides applied in crop, but we haven't actually got any results that we can be confident to report at this stage. More broadly in the herbicide space, of course, we know that in general, the group Bs as soil residues will affect nitrogen fixation, particularly where intolerant varieties are used. So there's now a range of tolerant, group B tolerant lentils and Bendrock beans, for example. So if you think you've got group B residues, it's a good idea to use those. The other one that we often see when we get reports of poor nodulation early in the season and we do a bit of a trace back is Lontrol. So that's probably the other one to to just keep an eye on, make sure that you're not going back before the recommended plant back times.
Will there be any price point of difference when the new strain is available, or will it be the same price?
That's I guess, a commercial decision, but I wouldn't see any reason that there would be any difference in the price, because it will just be a straight replacement for the commercial strain.